Hello, everybody. Thank you for joining us for our 7th event. We are joined today by members just of our AoT committee for AoT Koeln. So Roya, Parit, and Vina, you might have seen this in our introductory video on YouTube, but we will all be contributing to the discussion today. And we're very happy to have another one of our committee members, a founding member, Aleena Baby. Aleena has completed her bachelor and master degree in India, and she's worked on a variety of topics ranging from cosmic microwave background to active galactic nuclei, pulsars, and now she works on interstellar medium. And now she'll give us a presentation telling us all about these wonderful auroras that you can see in my background, and what causes this and where you might see them even outside of Earth. So Aleena, thank you very much for joining us.
Thank you for giving me this opportunity. You stole my background, but it's okay.
I have a question. Has anybody seen an aurora in real life?
Yes.
Never.
No, nobody has. No. Yes, I have seen the aurora personally. Aurora Borealis, not Aurora Australis. Growing up in Canada, this is easier to see. I mean, a bit further north, there's a lot of space, a lot of dark sky conservatories and places that they keep dark. And so they try to keep the light pollution out. That's a lot harder here in Europe because there's such a high density.
Yeah.
But in Canada, I remember times when we would go camping and then sometime at night, we would have the Aurora Borealis ahead of us. Usually just the greens and blues, sometimes some red, but I think Aleena will tell us what all these colors are. But yeah, Aleena, you can share when you're ready.
Sure. Okay. So today we will be discussing about aurora or polar lights. But when I say aurora, I don't know what does the first thing come into your mind. So it would be nice if you could write on the YouTube comment section what you think about auroras. So when I heard about aurora for the first time, the first thing came into my mind was the Disney princess or the Sleeping Beauty, who is waken up by the kiss of true love, or maybe the song Into the Unknown from Frozen 2, who was sung by Aurora. But actually, unfortunately, we are not talking about any of these things. And I'm talking about a natural light display seen in the high latitude regions. So aurora in Earth's northern hemisphere are called Aurora Borealis, and their southern counterpart, which light up the Antarctic skies in the southern hemisphere, are known as Aurora Australis. The name Aurora comes from the Greek goddess of dawn, and Aurora Borealis in Latin means northern dawn. The first recorded incident of aurora is from Babylonian time. A clay tablet recording numerous celestial observations were made by the official astronomers during 37th year of King Nebuchadnezzar II, describes an unusual red glow in the sky at night. The exact date of this observation corresponds to the night of 12th or 13th March in 567 BC. The most likely interpretation of this phenomenon is an auroral display. This event occurred several centuries before the first clearly identifiable observation of the aurora from elsewhere in the world, namely 193 BC in China. These auroras always fascinates and also terrifies humans, and every northern culture has oral legends about aurora. So people believe that these polar lights are a bad omen; they bring war or something like that. The aurora was, for example, described as heavenly battles or candles, and some interpreted as it as a reflected firelight from the Arctic ice or reflection of ice crystals in the sky. Henry Cavendish made quantifiable observations of the aurora in 1790, and he estimated that this aurora light is produced around 100 to 130 kilometer in altitude. In 1902 or 1903, Christian Birkeland, a Norwegian physicist, concluded from his Terella experiment that auroral light was caused by the currents flowing through the gas of the upper atmosphere. And this is exactly how our modern day neon lights work. So if you ask me what is a Terella experiment, I can show you some of the details about that. So a terrella is Latin for little earth. It's a small magnetized model ball representing earth. You can see Christian Birkeland, who was trying to do the experiment, explain why these light of the polar aurora appeared only in regions centered at the magnetic poles. So he simulated the effect by directing cathode rays at the terrella in a vacuum tank, and found that they indeed produced a glow in regions around the poles of the terrella. Because of residual gas in the chamber, this glow also outlined the path of the particles. Neither he nor his associate could understand why the actual aurora avoided the area directly above the poles themselves. Birkeland believed that electrons came from the sun, since large auroral outbursts were observed near to the associated with the sunspot activity. So before I tell more about these aurora and why or how it is created or caused, I would like you to understand two terms. One is solar wind, and solar wind is created by the outward expansion of plasma. Plasma is a collection of charged particles from the sun's corona. Corona is the outermost atmosphere. This plasma is continuously heated to the point that the sun's gravity cannot hold it down. So these stream of charged particles will be released from the upper atmosphere of the sun. And the second term I want you to know is coronal mass ejection. It is a significant release of plasma and accompanying magnetic field from the solar corona into the surrounding regions. So Earth is constantly bombarded with debris, radiation, and other magnetic waves from space that could threaten the future of life. Most of the time, the planet's own magnetic field does an excellent job of deflecting these potentially harmful rays and particles, including those from the sun, these particles from solar winds and coronal mass ejections. So, when one of the coronal mass ejections collides with Earth, it overpowers the magnetosphere and creates a magnetic storm. The heavy storm stresses the magnetosphere until it suddenly snaps back like an overstretched elastic band, flinging some of the detoured particles towards Earth. The retracting band of the magnetic field drags them down to the aurora ovals, which are the locations of northern and southern lights. So these particles discharged from the sun travel around 150 million kilometers towards Earth before they are drawn irresistibly towards the magnetic north and south poles. As the particles pass through Earth's magnetic field, they mingle with atoms and molecules of oxygen and nitrogen and other elements that results in this dazzling display of lights in the sky. So in short, sun emits charged particles. These particles from the solar wind will be captured by Earth's magnetosphere, and these particles are drawn up to the Earth's magnetic poles, and the excited electrons emit energy in the form of light, and that's how auroras are formed. So my next question is, okay, auroras are so beautiful and you can see them like this. And what makes these colors? Do you have any idea? No? You can write it down and I will read it later. So the colors are most often associated with Aurora Borealis are pink, green, yellow, blue, violet, and occasionally orange and white. Typically, when the particles collide with oxygen, it gives yellow and green. And when it has interactions with nitrogen, produce red or violet, occasionally some blue colors. And if it is atomic nitrogen, then we will get a blue, and molecular nitrogen gives a kind of purple color. So the colors are also affected by the altitude. The green lights typically appears in areas appear up to around 150 miles high, and red is above 150 miles, and blue usually appears up to 60 miles or around 96 kilometers, and purple and violet are above 60 miles. So these lights may manifest as a static band of light, or when the solar flares are particularly strong, as a dancing curtain of colors. The shape of the aurora, actually, what causes this shape variation from these curtains or strands is not well known, but the theory says that shape of the aurora depends on where in the magnetosphere these electrons came from and what caused them to precipitate into the atmosphere. And dramatically different auroral shapes can be seen in a single night. So these auroras are often visible at high latitudes, and Aurora Oval is the region currently displays an aurora, um, and Oval is located between 65 and 75 degree latitudes. Oval ranges from 500 to 1,500 kilometer in width, sound statistically defined. So this is an image from NOAA Space Weather Prediction Center, and this aurora prediction from yesterday, 3/3/21. So this is the probability of aurora, you can see. Maybe we can go and check what is the prediction for today. So this is the prediction for today, and it's currently, it's prediction for, okay, let's see. And it says that today you have less than 50% of chance to observe aurora, and it's when if it is going towards more reddish in color, then we can say like, okay, we can say you can actually observe aurora. The other thing which depends on the okay, one second. So the other thing which depends on the creation of aurora is this the global geomagnetic index. If it is a 6+, then yeah, probably you have a high chance to see aurora that day. Aurora often appears without any warning. Maybe there is no strict schedule. You can get a 30 minutes warning. That's the highest. So, and it also depends on the solar cycle or the solar maximum and minimum. You all know that sun have a 11 year of activity period, like 11 year it have solar maximum when sun is maximum active, and then 11 year of solar minimum when sun is uh, having a less active. So from until 2021, sun will be in its solar minimum time, and from 2022 to 2027, it will be the next solar maximum, and you can observe auroras more frequent. And so this is if pandemic over by 2022, then you can plan a trip to Oh, I didn't say where you can go. So you can go and like watch. So the best places in the world are usually closer to the Arctic Circle. So including Alaska, Canada, Iceland, Greenland, Norway, Sweden, and Finland. But don't limit yourself. You can also spot the southern lights in the southern hemisphere. Still, the northern lights are the star of the show. So in order to increase your chance of seeing this spectacle, you should time your trip to the new moon. Since the northern lights can appear and disappear in a snap, it's important to be alert throughout the night. Okay. And another tip is like, as usual, sky should be clear, dark, and free of clouds. So April to August is the best time to see. And if you are going, of course, you don't forget to click pictures. So when it comes to taking pictures, every photographer have his or her own will to or her own approach in taking a perfect photo. But the biggest misconception is that you need like a very expensive high-end equipment to get the job done. But no, you just need a camera and a tripod. You can use a traditional camera or a mobile phone or tablet or anything. But before you get out, just make yourself like familiarize yourself with the um, settings of the camera. So if you need more, if you want to learn more about astrophotography, you can comment below and we will also make a video about that, and we can discuss those settings later in time. But if you want to get some fancy kind of gears, then you can check for, I will suggest you to use a remote trigger, because once you set your tripod and your camera, then you don't want to mess the alignment or something. So it would be always good to have one. I only talked about the aurora in Earth, but there are auroras beyond Earth also. So the first one I will talk you about from Mars. At Earth, aurora are commonly seen as colorful displays of light in the night sky near the polar regions. You remember in the TV series The Expanse, there is a short scene where one character comments on the oddness of seeing northern lights on Mars. Northern lights, or more generally the auroras, are common in Earth because of its thick water-rich atmosphere and strong magnetic field and things. But in present day, Mars is dry and weak magnetic field. So they were talking about why it is aurora is visible in Mars. So in Mars, we can see the proton aurora. It is happening during the day and gives off ultraviolet light, so it is invisible to the human eye, but it is detectable to the imaging ultraviolet spectroscope instrument on the MAVEN. MAVEN is an acronym for Mass, Atmosphere, and Volatile Evolution spacecraft. Proton aurora form when solar wind protons interact with the upper atmosphere on the um, upper atmosphere on the day side of the Mars. When those high-speed incoming atoms hit the atmosphere, some of their energy is emitted as ultraviolet light.
I have a question here, if that's all
Yeah,
right.
sure.
I find it a bit strange that on Earth we have the auroras on the poles because of the magnetic field,
Yeah.
and here it's visible on the sun side. Why is that?
Yeah, it's mainly because of the magnetic fields are not so strong compared to Earth.
And so the particles are not deflected to the...
Yes, yes. The particles are not deflected to the polar regions. And another reason, because it is on the daytime, usually in Earth, you need like a dark sky to see aurora. It is because, in Mars, you have this water in the atmosphere, which will be evaporated during the daytime and goes up to the atmosphere, and the it will be break into hydrogen and oxygen because of the ultraviolet light. So these molecules are responsible for this aurora here. And also this aurora is seasonal because when it is warm enough, this warm water is like, evaporate and go up.
Okay. So this blue haze around Mars is, what is that?
It's the hydrogen corona of Mars.
Okay, so it's kind of like the upper atmosphere. So that's
Yes.
what interacts with these particles.
Yes, yes.
And so the hydrogen and the water is interacting. No, so hydrogen from water that has evaporated on Mars is interacting with protons from the sun, right?
Yes,
And that's why it's UV, because Lyman lines are created.
yes.
Okay, cool. But I have another serious question. How do you get auroras only on the poles when the Earth is flat?
So first of all, we are not saying, sorry. First of all, we are not saying Earth is flat. So if Earth is flat, we don't have that much magnetic field lines, right? So you will not have an aurora at all. And I will not be here to answer this question.
But if you think about it, so basically, if the Earth's poles are basically doing all the work, because you have one pole and another pole, and the lines are going into the poles, magnetic lines, and all you need is basically a very strong magnet, right? So if you have a very strong magnet, the particles from the sun will come to you and ride along the lines and then create this shiny thing, right? So do you think I could get a really big magnet in front of my house and create an aurora, like local one? Because
No, but you have to, auroras are more visible in like, 100 to 130 kilometer up from the sea surface. So you have to go up. So you
so
can take your magnet and go up, and then we will see how it is going to
Right
happen.
in the upper atmosphere.
Yeah.
so I can just put a magnet on a plane and then basically just shoot the plane into the sky and get an aurora bomb. That's cool.
Yeah, it will be literally a bomb.
Wow. Cool stuff here. Okay, serious questions, please, guys.
Where else are auroras visible besides Earth and Mars?
Yeah. So you can also see auroras in Jupiter, Uranus, Saturn, and recently we found out that beyond our solar system also we have auroras. Like recently we found out that brown dwarf in have an aurora. That's the first time we encountered that outside our solar system we have auroras.
We also have a question from one of our viewers.
Mm-hmm.
Right? So he was commenting on the, you showed the probability of seeing the aurora on Earth. I think that was from a website, right?
Yeah.
He was just wondering what makes this, he was noting that it's more probable to see the Aurora Borealis on the night side of the Earth. And he was saying what makes this probability. Do they also take into account like the brightness of the sky and how much light there is in the atmosphere? Or is there some other reason that we're more likely to see the Aurora Borealis on the night side of the sun or night side of Earth, opposite direction of the sun?
Yeah, it's one reason is like even if aurora is there on the daytime, then you cannot see because of the sun's radiations, right? And that's one thing, and you really need a clear sky to see that. And about this website which I just showed, It is from the space administration of it's Space Weather Prediction Center of National Oceanographic and Atmospheric Administration website. So what they do is basically they can calculate the coronal mass ejections from sun, and then the geomagnetic index, how this activity is going on, and they create a model based on those things, and then they predict how uh, likely that you can spot aurora tonight.
Yeah, Aleena, can I ask some questions? So,
Yeah.
like other planets in the solar system, are there also some detection of aurora in solar system moons?
Yeah, coming to Jupiter, auroras are like formed by particles ejected mostly from the moon, like Io, and Io volcanoes spew huge amount of sulfur and oxygen into the space, loading Jupiter's magnetic field with particles, and this is how Jupiter is getting auroras. So
they are also in the polar regions, like
yeah.
okay. And do we see it in optical or in any other?
I think it's in UV.
Mhm.
No, I don't think we saw it in.
So for Jupiter and Saturn, this isn't really dependent on the solar activity, and we don't need all the coronal mass ejection from the sun to create the auroras on Jupiter and Saturn, right?
Really?
Is that what you?
So
They
does it
get
mean
the
it's permanently there?
Yeah, for Jupiter's it would be like that because the volcanoes from Io is erupting so much, and if that activities are higher, then you will get particles all the time, and it's kind of, so it's not only sun causes these auroras.
So there's non-solar auroras. That's really interesting.
Yeah.
so if the moon had some volcano on it, then we would always have more auroras.
Yeah.
Yeah.
I knew the moon
Okay.
is boring.
Okay, we can apply for
Another moon.
Yeah, another one.
I think we should get Titan here or something.
But Aleena, if somebody want to conclude the first part of your presentation, is that correct to say mainly for having an aurora, we need a magnetic field, and the moon or satellite have a kind of atmosphere?
It's not necessarily I think like by atmosphere you mean something like Earth have, right?
Mm-hmm.
Yeah, but when you see to Jupiter or Mars, you can see that if you consider Mars, it doesn't have that much um, magnetic field compared to Earth. So magnetic field is not that necessary to have an aurora, but for atmosphere, I say you need particles to collide and mingle with the
Interact.
solar winds or anything, and to make the light. So it really depends on the concentration of particles on the atmosphere.
Okay, then you also mentioned that, and we know that in our own planet, the aura is colorful, and maybe it's our wish, maybe not for Craig, for the rest of people who are here to at some point see the auroras. But do you know why they are emitting in ultraviolet in other planets? Because I have searching on the internet, and when you are searching for Jupiter auroras or Saturn auroras, they are also colorful, but it seems like they are not, right? So do you have an explanation for that?
So the images we see are basically we do the false color imaging, and then we create also the GIF I showed in the video, like for the Mars. It's just a artistic impression. So most of the time it's either a false color imaging like that, or I don't know.
So if we had UV eyes, maybe it would look more colorful.
Yeah. So, and then is it correct to say the further out we go in our solar system, the auroras are getting into higher frequencies, or what is it like? Or is aurora on our own planets have also emission in ultraviolet that we cannot see that? How is the case? Do you know?
Yeah, that's a very interesting point to note. I don't know whether we have observed something in UV. I never heard about it. But if someone heard about it, then you all can
Yeah, sure.
educate us. Yeah.
I hope we could talk to dogs, because dogs can see in UV, right? And maybe they like huskies see UV auroras all the time, and they yeah.
Yeah. Yeah, but we also need a translation system to be able to understand what dogs are seeing.
Yeah, we can wait for them to evolve and speak with humans, and
Nice, yeah.
or we can build a spacecraft or something and see.
But so this really daring kid asked me a question once, that because he said that, what happens when you go through a molecular cloud or a nebula? Like, what do you see there? So I was puzzled, because it was like not happening soon, and can't really go there. But maybe we have a similar sort of experience going through an aurora, right? But the question is then, will we also have the added experience to like see or no, like taste it or hear it, or I don't know, feel it somehow? Do you think that works?
So I think I never experienced Aurora, so Craig would be the best option we have to answer this question. So Craig, do you have anything?
I've never heard the aurora, although at that point when I've seen the aurora, I wasn't really as into astronomy as I am now. So maybe I wasn't just paying attention. But yeah, that would be interesting to know.
But in
Rina
internet
mentioned
you
that.
can listen to the hissing sound of auroras. It's available on the net, so you can
Nice.
listen to the sound. Okay, if I have to, if it's a wild guess. Okay, aurora is more like an electric ionic phenomenon, right? So I guess if I am able to touch it, then it would be like I'm touching electricity, maybe.
So
It's a
goosebumps.
wild guess.
So you will get goose. I mean, you will get goosebumps anyway when you look at the aurora. But like, maybe it's not because of looking. Then
yeah, I don't know.
Yeah.
So maybe after a year, when the pandemic over, we can all go and plan a trip and go and experience this.
Interesting. So I was just making this comparison to Mars for Earth. If there's no magnetic field on Earth, would we always have a faint glow in the sky? Or would this be? Would it like never be completely dark, or would we always have a faint glow in the sky because of the interaction?
Yeah, that's true.
But I guess if you don't have any magnetic field, you don't have atmosphere also, right? Because it will be completely ionized by the incoming radiation from the sun. Is that right or not?
Yeah, I think
but
so.
at least sometime you will have a glow.
Because magnetic field is a very good cover for the planet.
Yeah, atmosphere. And without the atmosphere, I guess you won't have the glow, right? Or am I missing something?
You need the ionosphere.
Like without magnetic field, Craig mean like lesser amount compared to Earth, or just 0.
Gone, if it wasn't there. Anyways, we have a question from the audience. Are there any equipment or anything to view the auroras in the daytime as opposed to the night side? Or can we only see it in the night sky, on the night side of the Earth?
Yeah, I am not aware of any experiments we have currently for viewing it daytime, but that would be cool.
That'd be a good research proposal.
Yeah.
But I don't think so, because the light of the sun is pretty much brighter than anything else, right? So I'm not sure what exactly the illumination or the strength of the aurora is, but like you will have to have a really strong emission for any light to be seen.
It would be a hard experiment to set up. I imagine you'd have to send something up into a balloon and take it from the upper atmosphere near the pole.
Mm-hmm.
And
Also,
looking away from the sun.
These places where you see aurora, these are the regions where you have like these long nights and long days, right? So you may have like twilight like condition during the daytime, during polar winter maybe. That time maybe you will be able to see faint glow in the sky. I'm guessing that.
It would be interesting to see this transition between the night side and day side.
Mm-hmm.
Also, I guess there are a whole bunch of images from ISS of astronauts on the International Space Station that have taken a picture of the auroras from there. And so they've taken it off of Earth, and you can see these polar caps and the auroras there. So I imagine that with those pictures, you could see maybe there's something in the day side.
Oh, but also you have to consider that there's a lot of other radiation from the sun coming on in the daytime, because we expect this residual solar wind to sort of be retransported to the poles, and that's how it creates the emissions, right? But if you have the full wrath of the sun at some point on Earth, then you're also getting other particles which are, in competition to sort of, get noticed. So I'm not sure if that's really possible. But then we have Mars. So yeah, good question.
Very difficult to filter out all other things from sun and then specifically see aurora. So you will never know. Maybe someday someone will come up with some idea.
A bunch of questions to initiate a lot of research.
Yeah.
Hopefully, that's what we want.
Yeah.
But
I'm just
nice. Yeah.
I'm just happy with the aurora bomb. I don't need a PhD to do. That sounds much more dramatic.
But I do have like another question. I'm curious why we don't see any aurora in Venus, provided that Venus has a thick atmosphere.
I don't know.
I guess Venus does not have any magnetic field at all. Like, it's worse than Mars.
How quickly does it rotate?
Mm-hmm.
Yeah, and it doesn't rotate exactly. Also, Venus has a thick atmosphere, so you can't really expect the particles to sort of penetrate the atmosphere and see something there, I guess.
They have a lot of phosphine, right?
Oh, yeah.
Yeah, actually with the fact that they cannot penetrate, I do not agree. I think anyway, the high energy particles can penetrate and interact with the atmosphere.
Okay.
But
I wonder if it has some sort of dayside glow like Mars. Magnetic field.
Is there any experiments like or spacecraft near Venus?
But I'm also thinking because Venus has like strong volcanic activity, right? So like you mentioned that in Io, for example, there is a lot of volcano, and then there are like particles ejecting out of this volcanic system. So Venus is even much more active than Io, I guess. So there should be a lot of charged particles in its atmosphere.
So
And also the Venusian atmosphere is like filled with sulfuric acid, right? So, yeah.
So Venus is like, everybody go away, I create my own aurora. But I mean, you have to also think about the temperatures on Venus, because if you consider the weak Martian magnetic field, the crust magnetism, when it leaks sort of at some places on the surface, that's what maybe creates the localized auroras, right? But for Venus, the temperature is already hundreds of degrees on the surface, and it might be that it just basically deactivates whatever magnetism is left from the crust. Could be why we don't even see that much aurora on Venus.
Yeah, maybe. A lot of nice questions.
Yeah.
But thank you very much, Aleena, for your presentation.
Yeah, thank you
This
so
was
much.
a very nice discussion to have. And if you'll stick with us, please, we're going to move on to some recent news in astronomy that Parit will give us.
Sure.
Thank you.
All right. I hope you see good.
Good.
Yes.
Okay. So after all the serious nerd chat, let's bring you the exciting astro news this past month. Actually, not really the past month, just past 2 weeks or something. Let's see what we have in store. The top news is, of course, the rover Perseverance landed on Mars successfully. Okay. Now, of course, you missed the live stream, because if you had seen the live stream of our AoT Koeln event last month, we did alert you and provide a link even. But lucky for you, we recorded the event. So maybe you can just go back and look at the recording of the event, and then look at the recording of the landing. And yeah, just follow our event next time. So Percy is on Mars. We call it Percy. Everybody calls it Percy because Perseverance is too long. The rover landed on the 18th of February of 2021 in the Jezero crater. So this Jezero crater is pretty interesting. I'll tell you why. But the rover will analyze the geology, the climate, and the atmosphere of Mars. Lots of biology is expected, and there's also eventually a sample return expected. So the rover will collect a sample. The European Space Agency and NASA will coordinate to sort of send a mission to get that sample back. So yeah, it'll take some time. So let's not get. As far as the astrobiology is concerned, the feature, this Jezero crater, was basically a lake bed that had water flowing into it about a few billion years ago. And this caused sediments to build up over time. And then there was a river delta. There was lots of clays. And while the lake is gone now, the scientists, we scientists think that there could be biosignature somewhere, in this 45-kilometer wide crater, and they're just waiting to be found. So it's very exciting what we find there. Maybe we just get some fossils of bacteria or something. It's very promising. Photos and videos of the landing were captured for the first time. They finally decided to put a little 1.5 megapixel camera on the lander. Good thought. I'm not sure about this 1.5 number, but it was pretty good quality, so maybe it's better than that. To what Aleena was discussing before, since we were talking about water on Mars that basically interacts with the solar protons, this water is generated by the hydrogen, which is derived from Martian water, as she mentioned before. And this water is in the process of being lost to space still, like whatever water is left on the surface of Mars. But if you think about it, this water could be basically so you could connect the rate of auroras to the evaporation of water on the Martian surface, right? And this could help the science that Percy is trying to do. Also interesting to know that Percy and most rovers these days have Twitter accounts, because what is an interplanetary mission without live tweets? So this is what the rover had to say shortly after landing on Mars. Sorry, I think this is the wrong rover. Let's try again. Okay, I think I got a lot of tweets from this. This is a parody account, I'm sure. Like, who says "Holy shit, I'm on Mars" when you land on Mars? I would say that. Yeah, okay, but I'm sure NASA does not talk like that. My battery is low. It's getting dark, and Venus is still a trash planet. Okay, don't get personal, Percy. Okay. Okay, yeah, this is more like it. So the moment that my team dreamed of for years, now a reality. Dare mighty things. This shot is from a camera on my jetpack. Captures me in midair just before my wheels touch down. Okay, that you can read on Wikipedia, but let me tell you what that is. So also this seems more inspiring. You know, that's how NASA works. Point to be noted here is that for the first time a rover was landed smoothly on a sky crane, which is basically a really heavy jetpack. And many firsts for space aviation were there in this mission. So that's not all, though. It was also exciting to see the first image of Mars from Percy's camera to confirm the landing. Just after the landing, people were really excited, and then they saw the first image. But think of the times in life you got so psyched about seeing a bunch of rocks. That's what you expect on Mars. But okay, let's have a look. Well, of course, it's Bernie and his mittens. I love the internet sometimes. We didn't need to hijack this image. It was supposed to be inspiring, but who says Bernie is not inspiring? Yeah, so yeah, okay, Bernie was there. I'm sure you recognize Bernie and his mittens. In fact, we had a little chat about it with a friend. I had a chat about it with a friend, and we had like a spontaneous caption contest, and this was the one that stole the day, right? Mittens on Mars by Bernie, send us. Yes, please send us. I know someone who's working on that, sending us to Mars. By the way, Craig, we should have a caption contest next time.
Yeah, sounds good.
SpaceX. SpaceX is launching things again. There is Starship number 10, which recently stuck the landing, actually just yesterday. SpaceX Starship experimental flight series managed to land, and dreams of getting people to Mars are closer than ever now, because this is supposed to be the Starship is supposed to be the final super heavy craft capable to take us there. This is not technically astronomy, but I mean, space thingies are kind of our domain, right? Because just like you propose to your soulmate when they're single, we astronomers see an empty flying tube, and we also propose to put a telescope on it. Sorry, but if if muggles didn't pollute the sky too much, like with their phone signals and blinding streetlights, like we wouldn't have to grab like any real estate we find and escape that pollution, go to the sky, and put a telescope anywhere we want. It costs a lot of money. It's just better to build it on the ground. But yeah, it's too late for that. Yeah, but good news is finally one version of the Starship stuck the landing, but it wasn't done being dramatic. You know, it was a really dramatic landing. You can see here, like it's like even the camera angle is really good. But yeah, it wasn't done. It exploded. So all the relief in the eyes of the fans and future Mars travel dreamers were too much for the rocket, took it personally, and just exploded. So just to be clear, the landing was done, but then it exploded later. Just like, just a tantrum. Yeah, but we are going good. This is the golden age of space, and lots of great astronomy happening and lots of great space travel happening. So stay tuned for the next version of our event. Over to you, Craig.
Thank you. Thank you. I have a couple of questions on some of this. Relating to what Aleena was talking about, is there some UV camera or something on Perseverance where we can look at the auroras from the Martian surface?
Really good question, actually. I think there is a UV camera on Percy, and maybe also I think on Percy, maybe also on Curiosity, but it's more of a spectrometer. So it's basically trying to look at the rocky stuff in the Jezero crater and find out using UV spectrometry what is there. But I'm not sure that it can look at the sky like that, because if you think about it, like, why would you send a rover to look at the sky when you can spend that money to look at the ground? Also, because you guys mentioned Maven before, Aleena talked about Maven. So Maven is the one satellite that is paid to do this. It's like it's specifically designed to look at the atmosphere and see this phenomenon of auroras, but I'm still not sure. Maybe in some extension of the project, maybe they just decide to look at the sky and see something. Another point, it's very hard to localize an aurora on Mars. Even though the whole surface is ideally illuminated, it's very hard to be exactly at the place where the aurora is occurring, because it's faint and it's more than the Earth, but still a lot localized. So yeah, I don't think NASA was thinking of doing this with the rovers.
Right.
And I think this rover is only going to be on a lake on Mars. It's not going to circle the Mars, right?
Yes.
It's not exploring the entire.
Yeah.
Okay.
Yeah, but following Craig's question, but do you think if this rover had some optical eyes, was it possible for it to see the auroras? Although it's ultraviolet, I thought maybe while passing through the atmosphere, it will be re-emitted in optical wavelengths, and then rover can see a very nice, colorful aurora.
Yeah, that would be nice. First of all, I'm not sure why you're asking me aurora questions, because I work with you guys. And Mars questions, I mean, would be good to be a Mars expert, but so if I don't think the visible stuff is there anyway. So yeah, I'm absolutely sure that there's no visible aurora on Mars, a visible wavelength aurora.
Even on the surface of the Mars, if the observer would be on the surface of the Mars, it won't be optical, right?
Yes, I think that, yeah, exactly. Because there's no way to do that, because we on Earth have oxygen, nitrogen, other molecules.
All of this is in the ionosphere, right? So you also need an ionosphere, and then it's the Bellman lines, I think, that we see. But on Mars, there's not much of a magnetic field, and it's not enough to ionize the atmosphere.
Exactly. I didn't even know that it had a hydrogen blanket. I don't know where that came from, but it's very interesting to know. Yeah, but I'm absolutely sure that we won't see a visible aurora on Mars.
Okay.
These events are for scientists as well as the general public.
Yes, sure.
I learned something too in this event, so
Yeah,
that was nice.
Actually, the composition of the atmosphere of many planets in our solar system is still not completely studied. So all these things are open to researchers.
I have a question more about Mars missions. So Perseverance was the third one to arrive last month, right? There were some more missions.
I think that
Do you know anything about them? I know that Perseverance was the first to land, but yeah, I was just wondering if you knew anything more about these other missions. It was the Hope mission and
yeah,
a Chinese mission. I forgot the name.
yeah, but yeah, I mean, those missions are largely just fancy cameras, I guess. I mean, of course, every mission has to have more abilities than before, and of course, they are doing good science. But what I would like to take your attention to is the Ingenuity Mars copter, because the Percy rover carries this Ingenuity, and
Yeah.
yeah. So it carries this Mars copter, and it is kind of a very seminal moment for aviation in space, because it's never been done before that we had a flying machine that we could control on another planet. So it's getting serious, guys.
How long does it take for a signal to go from Mars to Earth?
I think it's about a few minutes, 20 minutes, I guess, at the most, and a bit less at the when Mars is closest. So yeah.
Okay.
And
Yeah.
how long this rover is going to stay on Mars?
No idea. I haven't read about that. I was just too excited about its landing, so I forgot to find out like how long the mission is. But as I understand, these missions are usually extended. So Curiosity landed in 2012. It's still there. Opportunity blew everybody's heads off and just kept going and going, and now it's lost. But yeah, I guess
because I think this one is planned to come back at some point to Earth, because it's going to collect the samples from Mars, right? So yeah.
Absolutely, yeah. But I think the rover will stay there, and there will be some sort of mechanism which they will use to pick up the sample. So it will just leave the sample, and there will be some sort of rocket that could just take the sample up to yeah.
And do you know if it's the first time that we have some of these samples back, except our own moon?
Yes, exactly.
Okay.
Yeah.
That's an interesting milestone.
Yeah.
So
that's fascinating.
Yeah, we should be rich and or popular enough by then to sort of say, oh, please 2 grams for me. Otherwise nobody will like, or we will become the scientists who are working on that, but I think it's too late for that.
But what do you want to do with that 2 grams?
It's a secret.
You already took a flight and with the magnet, and you are already on the upper atmosphere. Leave something for us.
Yeah.
Okay, but yeah, that was very interesting. Some nice news from the past month. So thank you for that summary. But yeah, I think that is it for our event today for this month. Thank you everybody who stuck through for the entire video, or if you're watching it later, then thank you for watching us again to talk. Next month, we will be live with another member from our Astronomy on Tap Köln committee, Dr. Brant Gacius. I think he will talk about interstellar dust. You can learn about what that is, how that affects astronomers. Hopefully we'll talk about some of the history of it as well.
I will make sure to ask him questions about Pluto.
Sounds good. But thank you very much for watching, and we'll see you next month. Bye.
Bye.
Bye.